In this session, we're going to talk about logarithmics and exponentials. So with me here, I've got objectives. So we're going to talk about the properties of log functions. We're also going to talk about the properties of exponential functions. Then we're going further to discuss about base conversions, how you convert from one base to another of logarithmic functions. Then we're going to solve equations for logarithmic functions. We're also going to solve equations for exponential functions. Then after that, we're going to sketch each one of them. Now I've chosen fit because logs and exponentials, they are opposites of each other, or in math we say they are inverse, inverses of each other. So let's start with the basics. So what are you supposed to know? If I have a function f of x is equals to log, let's say log x and a. This is the general expression of the log function. So your a in this case is called the base. The x in this case is what you're finding. So in this case it is the input. So this is just the basic of how we write a log function. Now there are two types of logs function that you're supposed to know as far as logs are concerned. Okay, there's what we call number one, a natural logarithm. Number two, there's what we call a common logarithm. Now, what's the difference between the two? A natural logarithm is a log in base e. A common logarithm is a log in base 10. Now, a log in base e is also called inx. Okay. Now, the e in this case, which is the base, is called Euler's number. Now, this Euler's number is about 2.71828. So it is actually a number, okay, and it's an irrational number. So that is important for us to understand. Then what other thing are you supposed to understand? If you have a function f of x is equals to a to the power x. Now in this case, this is what we are calling exponential functions. They are inverses of log functions. So the a in this case is the base. The x is what we call the power or the exponent. So we're dealing with the powers, or what you used to call indices. Now there are two types of exponential graphs and functions. Okay, number one is what we call an exponential growth function. Number two, there's what we call an exponential decay function. Okay, so what is the difference in this case? For the one that is a growth, you find that the value of a, or your base, is greater than 1. Then for an exponential decay function, the value of a will be between 0 and 1. So this is how different they are. Okay, and it's very important for us to understand the basics. So on both of these topics, you have to know how to know about the properties of each, how you solve the equations, and how you sketch. So let's start with the logarithmic functions. What about logarithmic functions? Let's talk about some of the properties of logs. So rule number one is that if you have a log, let's say log of a and the base is a, as long as the log and the base are the same, you're going to say the answer is going to be a 1. Number 2 is, if I've got a log of 1 to any base is actually a 0. So let me give an example on this too. So if I've got a log for the first one, let me say there's 10 and 10. This will give me a 1. If I have a log of, let me say 2 and a 2, this will still give me a 1 according to the first rule. Okay, then the log of 1 is just equals to a 0. So that is important for us to understand. Then if I've got a log of a, then there's x, let's say to the power b. Because we have a power, what the power does, the power is going to drop, and the power, when the power drops, I'm going to have b log x, and our base is a. So that's how you are going to simplify that one. Let me give an example. Let's say you're told to find log 8, then you have a 2. So make sure that you simplify your expression. So this one will be log, the base is 2, 8 can be written as 2 to the power 3. So because of we have the power can drop, and when the power drops, I'm going to have 3 log 2 and 2. Okay, and 3, and you said this is just like rule number 1. Okay, because we have a log and the base is the same. Because of that, this will expression just be 1, and 3 multiplied by 1, that is just a 3. So that's how you're going to solve that one. So another rule that you're supposed to understand here is what if you have a log of x, a log in base e? A log in base e is the same as natural log or inx. Okay, so this is just a natural log, and that is very important for you to understand as we are going to move on further. You're going to understand. Then just like the first rule, if I've got natural log of e, natural log of e is the same as log in base e. Okay, it's the same as log e and e, like that. Just because of this, it means this will also give you a 1, just like the first rule, and that is very also important for us to understand. Then what if you are adding and subtracting logarithmics? What happens when you're subtracting? Let me say addition. When you're adding or subtracting logs, what happens? So if I've got a log, let's say log a plus I've got log b, and let me say the base in this case is the same. Let's say this is x and let's say this one is x. Because the base is the same, I'm just going to get the log and the base. Now according to logs, for logs it's a bit different. For logs, 1 plus 1 is not equals to 2. That is very important for us to understand. And for logs, 1 minus 1 is not equals to 0. Okay, so the logs, when you're adding two logs, actually you are multiplying them. Okay, so in this case you're multiplying a multiplied by b, which will give you ab. Always start with the first one that they've given you, coming to the second one, that is log of addition or subtraction. So here I can put a plus or a minus, it will still be the same. Oh, it's a plus actually, like that. If you're adding, that's what you're going to use. What if you're subtracting? So when you're subtracting, let me say I've got a log of, let's say, a minus log, let me say, of b. So when I've got such an expression, let's say the base is the same, let's say the base is x. So I'm just going to get log x, and what I'm going to do is I'm going to divide a by b. And this is another powerful principle that you need to understand. And these are some of the basics that you need to understand about logs and some of its properties. Now, how do you convert from one base to another? It is very, very important for you to know how to convert logarithmics from one base to another. Let me say I have a log of 2, or let me say log of 4 in base 2. So how are you going to, let's say they've told you to convert to base let's say convert to base 10. So how are you going to convert this one to base 10? So you're going to write your log. So write your log to 4 and write your log to 2, and now write the base to which you're converting to. As simple as that. So I'm going to write the log of 4 divided by the log of 2. To which base are we converting to? We are converting to base 10. So I'm just going to put the bases like that. And when I do that, I have converted from base 2 to base 10. Let's solve another example. Let's say I have a log. Let me say this is 10, this is 4. Then they tell us to convert to base 2. So how are we going to do that? So our answer will be log 4 divided by log 10. Then I put the base. The base here it is 2, and the base here it is 2. Now I can simplify what is on top. When I simplify what is on top, I'm going to have log 2. 4 is the same as 2 to the power 2 over log 2 and 10. Okay, so what am I going to have on top? We said when you have a power, the power drops, so I'm going to have 2, and this is multiplying by log 2 base 2. We said this just gives us a 1, so I'm going to put a 1 here over log 10 in base 2. Therefore my final answer will therefore be 2 over log 10 base 2. So this will be my final answer. So this is how you convert from one logarithm or from one base to another, and that is very, very important for us to understand. Why? Because it is what is going to help us to solve equations. So let's solve some equations on logarithmic functions. So what are you supposed to understand? We cannot solve logarithmics which are not in the same base. That's what is most important. So if, let me say I've got a log, just a normal one, let me say log x and 2, let's say plus, let's say 2 log, let's say x, the base is x, let's say this is also, let me say okay, let's make it interesting. Let's say log 2 and x is equals to 3. So how can we solve this one? Now you're able to see that the bases are different. This one is x, this one is 2. So it will be up to you to change to which base that you are familiar with. So for me, let's convert, let's say base 2, let's say base 2 to x. Okay, so if you're converting base 2 to x, we want this one. Okay, so because we want that one, so what expression do we have? We've got log 2. So we've got 2 log x and 2 So converting this to base 2, so what are we going to do? We're going to have our 2 log x divided by, I'm going to have log 2. Now to which base am I converting to? I'm converting to base x. Okay, so here I'm going to put x and here I'm going to put x. Now that I've got that, what now am I going to do? So what this now equates to is, because I've got x and x, the log in x and base x, those ones are going to give me a 1. So I'm going to have a 2 multiplying by 1 on top over log 2 in base x. And that's what I'm going to replace where we need to replace. So what will be our final? I'm going to have log 2 base x plus the one that we've just converted, which is 2 over log 2 base x. Okay, now that I've got this, how do I now solve this equation? Okay, so to solve this equation, I can let y is equals to log 2 base x, because I've got log 2 base x and log 2 base x here, so I can replace that by y. So what am I going to have? I'm going to have y plus 2 over y. So don't forget there is is equals to 3, even this one is equals to 3. We formed an equation. So what do? We have to solve on the other side, and after that we multiply by 3. Or what I'm going to do, I can multiply by y throughout. Okay, so when I multiply by y throughout, when I multiply y multiplied by what is his side, I'm going to have y squared. Then when the y multiplies with 2 over y, so 1y and 1y and y are going to cancel. I'm just going to have a 2. So I'm going to have a plus 2 is equals to, then y multiplied by 3, I'm going to have a 3y. Okay, so actually this one, y multiplied by y, you know that's y squared, so I forgot to put a square here. Okay, that is an equation, and if I write it in standard form, I'm going to have y squared. When the 3y comes to the other side, it becomes negative 3y plus 2 is equals to 0. Okay, so this is the equation that we have. So we have to solve this equation whether using formula method or just normal method. So let's see the product, the sum, and the factors. Let's check if these ones are going to give us that. So the product, in this case, it is a 2, the sum, it is negative 3. Two numbers, when we multiply them, they'll give us a 2, but when you add them, they'll give us a negative 3. Okay, so which ones are those ones? So if I have negative 2 and negative 1, when I multiply them, they'll give me a 2, but when I add them, they'll give me a negative 3. Okay, so those are what we have as our factors. So now how do we solve this one? So our job will be now to replace. So we're going to have y minus 2, we're going to have y minus 1 is equals to 0. Therefore y will be equals to 2 and y will be equals to 1. So these are the values of y. So if those are the values of y, what do we now do? We just have to now replace. We have said we have to let y is equals to log that. So how do we solve that? So y, one of the values of y, we found that it is 2. So 2 is equals to log x 2. Another one, it is 1 is equals to log base 2 x. Okay, so now how do we solve this one? I have to now introduce another concept. When you see that you cannot solve a log, always try to change it to an exponential function. So how do we convert to exponential functions? So it's from here that you're going to now convert. So the way you're going to do, since this one is the base of the log, and for an exponential, if we say f of x is equals to 2 to the power x, since 2 is the base, so it means that's what you are supposed to have as the base, and the base of the log, it will be the base as well of an exponential, but the powers, they'll be like different. So if that is what we have, so now what are we now going to have in this case? So in this case, if I've written that, let me just rub what I'm just written. Okay, so this is going to take this one as a power, and this will be equals to 2. Same with the other side. This, since it's a base, is going to take this one as a power, as an exponent if you want, then this is going to be equals to that. So that's how we're going to solve these ones, or to convert them to exponentials. So let me start with this one to the power 2. So I have x to the power 2 will be equals to 2. Okay, so now how do I remove this power? So I can multiply by half on both sides if I want, and if I multiply by half, this is 1 over 2, and I also multiply by half on the other side. So the half and the 2, they're going to just give us a 1, so x will be equals to the square root of a 2. Okay, so that's how we're going to solve this one. Then what about the other one? How are we going to solve this? So x to the power 1 is equals to 2. So we have x to the power 1 is equals to 2. So this one just gives us a direct answer. So that's how we're going to solve logarithmic equations, and it's as simple as that. Now let's talk about exponentials. What are the basics? Earlier we said f of x is equals to 2 to the power x. Just to remind you, when you're just introducing this session, we said 2 is the base, then x is the power, or what we call the exponent, and it is very, very important for us to understand. So essentially we're just saying an exponential function is that function with a number raised to a letter, and that is important. In high school we used to call this one indices, and indices have still come. So what are we talking about? Let's talk about some of the basic rules. Basic rules of these indices. Number 1, the product rule. If I've got a multiplying by a, and let's say they've got the same, this one has got the power of n, this one has got the power of m, because the bases are the same. So what I'm just going to get the base, and I'm going to add the power. So I'm going to have n plus m. That will be my answer. So an example that I can give is, if I'm multiplying 2 multiplied by, let me say 2, this 2 is raised to the power 3, this one is raised to the power 2. So my answer therefore is going to be 2 to the power 3 plus 2. Okay, that will just give me 2 to the power 5. To the power 5, that is about 32. Or you can even try it. This is 2 to the power 3, that is 8, multiplied by 2 to the power 2, that is a 4. A 4 multiplied by an 8, that is still a 32. So this is the same principle, okay, about indices. Now that we've talked about that, what is another rule? Another rule is, what if you are dividing? If I've got a divided by a, let's say n and m, so this is the quotient rule. According to the quotient rule, so what you're going to do, you're going to get the base because it is the same. So I'm going to now subtract the powers. Okay, so this now will be equals to, this is m, that's what it is. and that's how we solve that. Okay, so an example that I can give, let's say you've got 3 to the power 4 minus, let's say 3 to the power, let's say you're dividing actually, 3 to the power, let's say 1. So what are you going to have? You're going to have 3, 4 minus 1, and that is 3 to the power, that is 4 minus 1, that is a 3. 3 to the power 3, that is like, is it a 27? Is it a 27? Yeah. So that's how we are going to solve it. Not very much complicated. Okay, so you're able to see now that in logs, your division, your addition of logs gave you a multiplication. Your subtraction of logs gives you a division. But for the exponentials, it is the opposite. When you're multiplying exponentials, you're going to add the powers. When you are dividing the your exponential functions, you're going to subtract the powers. Very two concepts, but different arrangements. So that is about the product and the quotient rule. What about some of the power rules that we know? Okay, let's say a to the power 0. Any number to the power 0, it is a 1, right? What if about a to the power 1? A to the power 1 to just be a. Okay, what if I've got a to the power negative 1, a negative power? A negative power always translates to be 1 over a. Okay, and that is important for us to know. If I say a to the power negative 1, or let me say a to the power negative m, a to the power negative m, it will be 1 over a to the power m, and that is also important for us to understand. Then let's talk about another rule. Then we can call this one as rule number 4. If, let's say, what if you have a to the power a fraction, let me say x over y. So the way we're going to write a fraction, you're going to write what a is, what is the denominator becomes the power, it becomes the root, then what is on the numerator becomes the power. Okay, so an example that I can give here is, if let me say I have, if I have let's say 8 to the power 2 over 3, this will equate to, we'll find it will be the cube root of 8, then the numerator becomes the power. So in this case, a number that you're going to multiply 3 times by itself to give you 8, we know that it's just a 2. Then this is squared. Now 2 squared, that is just a 4. So that's how you're going to solve that one. Now what if you have, let's say you have 4 to the power half. 4 to the power half is just the same as the square root of 4, and the square root of 4 is just positive or minus 2, but in this case we're just going to get the positive 1, and that is very important for us to also understand. Okay, now that we've talked about how these important rules about exponentials, how do you find the equations? So equations on exponentials, these are the two conditions that they are going to focus on. They are going to ask you to find the missing base, or number 2, to find the missing power. Okay, so let's say we want you to find the missing power. So now that is one of the simplest one. Let's say 2 to the power x is equals to, let's say, 4. So how can you solve such a one? So you have to always make the bases the same. So in this case, I'm going to have 2 to the power x is equals to, how can I write 4? 4 I can write it as 2 to the power 2. Because the bases are the same, I'm just going to equate the power, so x is equals to 2, and we are done like that. Let's solve another one. Let's say we've got 2 to the power x is equals to a 1. How are you going to solve this one? So you're going to say 2 to the power x will be equals to, now a 1 is just the same as 2 to the power 0, right? Any number to the power 0, a 1. So x will be equals to, in this case, x will be equals to 0. Okay, and that's how you're going to solve. Now let's solve another one. What if you cannot make the base the same? Let me say 2 to the power x is equals to a 3. Now in this case, it will be very hard for us to make the bases the same. So because it's very hard, we're going to introduce natural log on both sides. Okay, now if I introduce natural log on both sides, what am I going to have? I'm going to have natural log of 2 to the power x is equals to natural log of 3. Then what do you remember for our logs? Because this is the power, it's going to drop. Okay, and when it drops, what am I going to have? I'm going to have x natural log of 2 is equals to natural log of 3. And because we're finding x, I'm going to divide by natural log of 2 on both sides. Therefore the value of x will just be natural log of 3 over natural log of 2. So that's how you're going to solve in case you have you can't make the bases the same. Let's solve another one. Let's say you have 2 to the power x minus 1 is equals to 16. So how are you going to solve this one? Make sure that the bases are the same. So you're going to say 2 to the power x minus 1 is equals to 16 is the same as 2 to the power 4. Or because of that, so I'm going to now just equate the powers. X minus 1 is equals to a 4. Therefore x in this case will be 4 plus 1, and x will be equals to 4 plus 1, that is just a 5. And that's how you're going to solve this one. Let's solve another example. Let's say you have x to the power 4 is equals to, let's say you have x squared is equals to 4. Now in this case, we don't know the base, okay, but we know the power. So how do we solve such kind of equations? So for you to do that, simply get the reciprocal of your power. In this case, the power, since it is 2, the reciprocal to be the opposite. So if this is our power 2, so this is our 2, so we're going to multiply by the reciprocal, which is 1 over 2 is equals to, on both sides. We know that 4 has a power of 1, right? So this will also have a half like that. So 2 and the 2, they are going to divide. So this side I'm just going to have x to the power, I'm just going to remain with x to the power 1, which is the same as x. Then when I come to the other side, I'm going to have 4 to the power half. Therefore x will be equals to the square root of 4. Therefore x will be equals to positive or minus 2. You know that if I put negative 2 there and I square it, or I put positive 2 and I square it, all of them, they are going to give us 4 on the other side. So meaning the two solutions are correct. What if I've got x to the power 3 over 2? How am I going to solve this one? Then let me say I have a root of 3 on the other side. So how am I going to solve this one? So it's the same principle, just write it in standard form first. X to the power 3 over 2 will be equals to, the cube root of 3 is just the same as 3. This is the cube root of 3. So this is just the same as 1 over 3. Okay, 1 over 3, yeah. Now for us now to remain with x on the other side, multiply by the reciprocal, which is 2 over 3 on both sides, 2 over 3 to the powers. Okay, so now what am I going to do? The 3 and the 3 are going to divide, the 2 and the 2 are going to divide. Therefore I'm just going to remain with x to the power 1, or x. Then when I come to the other side, what am I going to have? I'm going to have 3 okay, actually this is a square root. Whatever, this is a square root. If this is a square root, okay, so I made a mistake. So if it's a square root, I'm saying 1 over 2 here. Okay, if that is the square root, so this, the 2 and the 2 are going to divide. Therefore I'm going to just remain with 1 over 3. Okay, therefore my x now will be equals to 3 to the power 1 over 3. You know that the denominator becomes the root, which is a cube root of 3. So that will be our final answer. So that's how you're going to solve most of these equations. So let's solve another equation. Let's say you've got 2 to the power 2, let's say x plus 1 is equals to, let's say 3. You have 2, you have x minus 1. So how are you going to solve this one? So let's say the 1 is here. This is a big one. Okay, good. So if it is like that, how are we going to do that? We can separate where we've put the 1. So I can just say as 2 to the power 2 x. How was it initially? Meaning it was multiplying by 2 to the power 1 for us to have let me say, okay, like this is just fine. So I'm just going to say 2 to the power 2 x. Initially, how was it? It was 2 to the power 1, right? That's how it gave us the one that is on top. Okay, is equals to, then on the other side I've got 2 to the power x. So I'm going to have 3 to the power x minus 1. So now what am I now going to have? So I'll make sure that I separate what I have. I want it to have, this is 2 to the power x. I also want this one to also have 2 to the power x. So what am I going to do? I can separate it. I can say 2. I can put the x in, then I put the 2 outside. Multiplied by 2 to the power 1 is equals to, this side I've got 3 multiplied by 2 to the power x, then there's a minus 1. Now that I've got such an expression, I can look for a letter that I can replace throughout. I can let me say let p is equals to 2 to the power x. Now if I place wherever there's 2 to the power x as with the p, so I'm going to have p squared. P squared is multiplying by 2 will be equals to 3p minus a 1. Now that I've got that, this side I'm going to have 2p squared. When I take everything that is on my right hand side to the left hand side, I'm going to have negative 3p plus a 1. So that is an expression that I have, and that is a quadratic. So how do I solve this quadratic? Okay, so we're going to solve it like any other quadratic expression. So we have 2p squared minus 3p plus a 1. So what do we have? We're going to look for two numbers that when we multiply them, they're going to give us a product. So the product in this case, it is a 2. The sum, it is a negative 3. The factors, two numbers, when we multiply them, they'll give us 2, but when we add them, they'll give us negative 3. So negative 2 and negative 1, they are able to achieve that. So what are we going to have? I'm going to have a 2p squared minus 2p minus p plus 1 is equals to 0. Now that I've got that, I'm going to factorize. I'm going to divide my equation into 2. So okay, here side I can factorize a 2p. Here I'm going to just remain with a p minus a 1. When I factorize what is this side, I can factorize a negative 1. Therefore, I'm going to remain with a p minus a 1 is equals to 0. So because the p minus 1 is the same, I'm just going to pick 1, and I'm going to put 2p minus 1 in one bracket, and the p minus 1, just one of them, is equals to 0. Now I've got such an expression. This expression means that 2p minus 1 is equals to 0, and p minus 1 is equals to 0. So 2p will be equals to, when the 1 comes to the other side, becomes a positive. Then I'm going to divide by 2 on both sides. Therefore, p is equals to half. P is equals to half. What about the other p? P will be equals to, when the 1 goes to the other side, becomes positive. P is equals to 1. So those are the two answers that we found for p. But mind you, we're not finding p, we are finding x. Okay, so we have to let p to be equals to 2 to the power x. So p, one of the values of p, we found half, so half is equals to 2 to the power x. So another values of p is 1, so we have p is equals to 2 to the power x. We're saying another value of p is 1 is equals to 2 to the power x. So in both cases we're looking for the missing power, and initially that's how we were solving. So how can I write this one? 1 over 2, it says 1 over 2 is the same as 2 to the power negative 1, right? So this is equals to 2 to the power x. We've made the base the same. Therefore, because the bases are the same, we're just going to equate the powers. Therefore, x will be equals to negative 1 on this other side. Then on the other side, what are we going to have? 1 is equals to 2 to the power x. So how can we make a 1 also on the other side? So this is just going to be 2 to the power 0, right? Is equals to 2 to the power x. Therefore, x in this case is equals to 0. So that's how we are going to solve such kind of equations. So now how do we sketch these logarithmic functions? So when you're sketching, and let me start with an exponential function. Let me say it's here, then the logarithmic function is on the other side. So for the exponential function, if this is the y-axis, your x-axis always is the horizontal asymptote. Then on the other side, for the log function, if this is your y-axis, let me say this is your x-axis, the y-axis will be the asymptote. Now the asymptote is that graph is that line on the graph where you're not supposed to touch. So that's how these two are different, but otherwise they're just opposites of each other. So how do we sketch exponential functions? Let's say they've told you to sketch this one. So initially, if you are very stuck with graphs, try to come up with a table of values. So let's say this is x and this is y. Okay, and that is our table of values. Okay. If this is our table of values of x and y, so if we choose now, so it means when we choose, let's start from 0. If I put a 0 where there is x here, I'm going to have 2 to the power x to the power 0, and any number to the power 0 is a 1. So that means the value of y will be a 1. What if I put a 1? If I put a 1 where there is x here, I'm going to have 2 to the power 1, which is the same as a 2 as the value of y. If I put a 2 here, 2 to the power 2, that is just a 4. So if I put a 2, I'm going to have a 4. What if I put a 3? If I put a 3, I'm going to have what? 8. So 3 will give me an 8. What about if I put a negative number? Let me say I put a negative 2 here. Negative 2 will give me, if I put negative 2, so it is 2 to the power negative 2. That will give me 1 over 2 to the power 2, and that will be 1 over 2 to the power 2, that is a 4. 1 divided by 4, that is 0.25. So I'm able to see that I'm just getting positive numbers. Whether I've got a negative number, whether I've got a negative or a positive, that's what I'm getting. So now that I'm getting that, this what we have is enough for us to graph. So if let's say this is our graph, so how are we going to sketch this one? So if we are to put points, let's say we start from 0, 1. 0, 1, let's say our 1 is here for y. So 0, 1, maybe it will be this point, okay? Not really drawn to scale. Then we've got 1, 2. 1, 2, how are we going to show our 1, 2? Let's say our 1 is here, and let's say the value of 2 is here, so it's going to be somewhere there. Then let's say we have got 2 comma 4. Let's say the 4 is somewhere there and your 4 is somewhere there. Okay, that would be that point. If your 3 is there and it's comma 8, let's say our 8 is there, and like that. So you're able to see that this graph is going to be moving in that direction. Okay, passing through those points. So now it is cutting the x-axis at this point, and on the x-axis it's cutting the y-axis at that point, and on the y-axis or the y-intercept we know that x is equals to 0, and which we did replace x to be equals to 0 and gave us a 1, which is this point. So that's how you graph your exponential function. So let's solve another example. Let's say you have f of x. Let's say is equals to 4 to the power x. So how are you going to solve this one? Now, we're not going to write what we're writing, but if you're stuck, you can do that. We are going to just use now simple principles for you to understand what we're talking about. Let's say this is our y-axis, this is our x-axis. So always look at the value of x and look at the value of y. The value of x in this case, look at the value of x, it is positive. Okay, so meaning you're going to the positive values of x. What about the value of y? The value of y is value of the whole function. The value of the whole function is positive, so also going to the positive values of y. So how is our graph going to be? It's going to move in this direction, going in that direction, and it's going to cut this point. On that point is the y-intercept. On the y-intercept, x is equals to 0. So if I put a 0 here, it will be 4 to the power 0, which is 1. So here it is just a 1. So that's how you're going to graph this one. Let's graph another one. What if you've got f of x is equals to, let's say, negative 3 to the power x. So how are you going to solve this one? So you're going to, let's say this is our y-axis, this is our x-axis. So you have to again look the value of x and the value of y. Now look at the value of x. X here is positive, so we're going to the positive values of x. The value of the whole function, it is negative. You're going to the negative values of y. So how is our graph going to be? Okay, so you only have got two choices. Here x and y are both positive. Here x is negative, y is positive. Here x is positive, here x is negative, y is also negative. Here x is positive, y is negative. So it means we are going in this quadrant. So because we are going in that quadrant, now how are we going to show that? So it means we also have to find the y-intercept. Where is cutting the y-axis? So where is cutting the y-axis? We know that x is equals to 0, right? So if I put negative 3 to the power 0, that will just give me negative 1, right? So that is where it's cutting the y-axis. So let's say the negative 1 is there. So how are we going to go? It means we're going in this direction, but we're going in the other direction like that. So that's how we are going to the positive values of x but the negative values of y. So let's solve another example. Let's say you have f of x is equals to 3 to the power negative x. So how are you going to solve this one? So let's say this is our y-axis, this is our x-axis. So you have to look at the value of x and the value of y. Okay, now what is the value of x? Look at the value of x. X is negative, so we're going to the negative values of y, x. Then the whole function, it is positive, so we're going to the positive values of y. So where is x negative and where is y positive? So you know that it is in this region. So now we have to look at the intercept. So the intercept, x is equals to 0 on the y-intercept. So it will be 3 to the power negative 0, okay? Which is just the same as, there's nothing like negative 0, there's nothing like positive 0. 0 is neutral. So this is the same as 3 to the power 0. 3 to the power 0 is just a 1. So this is passing through 1. So it means it's going to go in this direction, going in that direction, and this is 1. So that's how you are going to solve that one. Let's solve another one. Let's say you have f of x is equals to negative 3 the power negative x. How are you going to solve this one? So look at the value of y, look at the value of x. So the value of x, you're able to see that in this case it is negative. The value of y, it is also negative. So when you draw your x or y plane, this is the y axis and this is the x axis. Where is y and x negative? It is in this region. So now where are we now going to pass? We have to know where we're going to pass. We have to find the x-intercept. On the x-intercept, y is equals to x is equals to 0. Okay, so therefore we're going to have negative 3 to the power 0. Negative 3 to the power 0 is just negative 1. Now that we've got that, it means we're passing at negative 1. That's why it's cutting the x, the y axis. So it means we are going in which direction? We have to go, it means we are going in that direction. Okay, so this is our 1 where we are cutting the y axis. So now that we've got that, we've done that, what if we solve another one? Let's say you have f of x. Let's say it is equals to 2 to the power x minus a 3. Okay, now we've introduced a shift in the y direction. So let's say this is our y axis, this is our x axis. We said this acts as the barrier or the asymptote that we are not supposed to cross. Okay, and this is x is equals to 0. But now what if we now put a negative 3, meaning we've shifted our shift from 0, now we have shifted it to negative 3. So it means our graph is not going to touch this point. So this will be our shift, the point that we're not supposed to touch. So we also have to find where it's going to cut the x and the y axis. First, let's find the x and the y in terms of the signs. X is positive, so we're going to the positive values of x. The whole function is also positive. We're also going to the positive values of y. But what about on the y-intercept? The y-intercept, x is equals to 0. So if I say 2 to the power 0 minus 3, 2 to the power 0 it's 1 minus 3. So I'm going to have 1 minus 3, that is just a negative 2. So it means we're cutting the y-axis at negative 2. So let's say our negative 2 is here. If our negative 2 is there, it means we're going in this direction, which is correct. But now we've cut another point here, so we're supposed to find this point. So what is this point? It is on the y, it's on the x-axis. On the x-axis, y is equals to 0. So I'm going to say 0 is equals to 2 to the power x minus 3. So how do we find x? I'm going to take the negative 3 to the other side, and when I do that, I'm going to have 3 is equals to 2 to the power x. Now how do I now find x? I'm going to introduce natural log on both sides. So I'm going to have natural log of 3 is equals to natural log of 2 to the power x. So this side I'm going to have natural log of 3 is equals to, the x is going to drop. When the x drops, I'm going to have x natural log of 2. For me to remain with my x, I'm going to divide by natural log on both sides, natural log of 2 on both sides. Therefore my x will be therefore equals to natural log of 3 over natural log of 2. So this point is natural log of 3 over natural log of 2. Okay, so that's how you're going to solve it, provided you're not given a calculator in the exam. Okay, let's solve let's say the last question on exponentials. Let's say you have f of x is equals to 2 minus 4 to the power, let's say, negative x. How are you going to solve this one? Let's say this is our x and the y axis. So what do we now do? So we have to look at the value of x and the value of y. We see where it's going. X is negative, so because x is negative, we're going to the negative values of x. The whole function is positive, so we're going to the positive values of y. So it is in this, it is in that region. So because it is in that region, where are we going? So actually, not really. Oh, I've mistaken the whole function. The whole function, this is negative 4 to the power negative x. So that is, the whole function is also negative. This 2 here is just a shift. Okay, so this is negative. We're also going to the negative value. So it's in this region. So if it's in that region, how are we now going to solve? We have to find the y-intercept. Now we also have a shift, so we have to put a shift. We've shifted the graph from 0, 0, this one, from 0, x is equals to 0 to 2. So meaning, let's say our 2 is here, so it means we're not supposed to, this one will act as a asymptote. So how are we going to go? So our graph can come like that, it can pass through 0, 0, or it can come like that. So which of these three graphs are we going to find? So we can only do that, we can only determine that by finding the y-intercept. So that would be f of x will be equals to 2 minus 4 to the power, in this case x is equals to 0 on the y-intercept, so I'm going to have 2 to the power 4 minus I'm going to have 2 minus now 4 to the power 0, it's just a 1. 2 minus 1, what do I get? It's just a 1. So it means it's cutting the y-axis at 1, 1. Therefore this graph is coming like that, passing like that, and it's going like this. Now we've cut the y-intercept, the x-intercept there. On the x-intercept, what is y? Y is equals to 0. So we also have to find that point that I've just shown by an asterisk. So on the was y is equals to 0, so we have 2 minus 4 to the power negative x. So I'm going to take the negative 2 to the other side. I'm going to have okay, let me take the 4 to the other side. So I'm going to have 4 to the power negative x will be equals to 2. Okay, now that I've got that, what do I do? I can make the powers the same, or the base the same, because we've learned indices. So I'm going to have say 2 to the power 2, this is multiplying by negative x, is equals to 2, okay, which is the same as to the power 1. So now what am I going to do? To the power negative x, I'm going to have negative 2x is equals to 1. For me to remain with x, I'm going to divide by negative 2 on both sides. Therefore my x will be equals to negative half. So this is the same as negative half, where we're cutting the y-axis. So that's how we're going to solve, you know, exponential graphs. We solved literally like a lot of them. Let's solve some, but in closing, let's solve some logarithmic graphs. So what is the basic? Let's say f of x is equals to the log of x. So how are we going to solve this one? Now earlier we said for the log function, the y-axis acts as the horizontal asymptote. You are not supposed to touch that line. Okay, so that's what you are supposed to understand. So how are we going to solve this one? Let's come up with a graph. If they haven't given us the power, let me say if they haven't given us the base, always assume that the base is 10. Okay, a 10 is a natural log. It's a common log, not a natural log actually. So this is, let's say this is our table of values. Okay, if that is our table of, let's say this is x, this is y. Now that we've got that, what are we going to do? Let's start from, you can even start from 1, let's say 100, let's say 1000. The log of 1, we said it is 0. Log of 1 is always 0, okay? The log of 100, that is a 1. The log of 1000, that is the log of 100, that is a 2. Log of 1000, that is a 3. So the more you have zeros, the more the log is also increasing. That's what I mean. So if I have a 0, if I've got 2 zeros, that will be 2. If I've got 3 zeros, that is a 3. But now, how do we also determine that? We've learned if I'm finding log of 100, how am I going to find it? It's the same as log, because the base is 10, like I've told you. If they haven't given you a base, the base always assumes that it is 10. So I'm finding log 100 of log 100 or in base 100. So what are we going to do? You're going to write this one as log of 10. Then if they haven't given you the base is 10. So now 100 is the same as 10 to the power. Is it 10 to the power 10? 10 to the power 2 actually. 10 to the power 2. It means we're multiplying 10 multiplied by 10. Now that we've got that, the 2, because it's a power, can drop, so I'm going to have 2 log 10 and 10. And we said this whole expression gives you a 1. Therefore, we're just going to remain with a 2. That's the 2 that we've written there. So same with 3. If I had log of 1000, if I had the log of 1000, if I put a 0 here, even this here is 0. So this, it means I'm going to have a log of, this is 10, this will be 10 to the power 3, right? Yes, and the 3 is going to drop. So I'm going to have 3 to multiply by 1. And 3 multiplied by 1, that will just be a 3. And they'll be going like that. So those are the answers that we're going to get. Then there is no log of a negative number. So we can't just say log, because that's why I've started from 1. Because you can't say log negative 1. There is no negative log of a negative number. It's undefined. So because of that, that's how we are going to now plot. Now that you got everything, you just have to now plot your graph. Let's say this is our y-axis, this is our x-axis. Okay, so how are we going to go? We also have to look at the value of x and the value of the function. X here is positive. We're going to the positive values of x. The value of the function, this function, is also positive. We're going to the positive values of y. Okay, so where is x positive and where is y positive? So it means we're going this direction, going that direction. Okay, so we said this is the asymptote. We're not supposed to touch that line, and that's how we are going to go in terms of log functions. So this is the basic one. Let's solve some more. Let's say you have f of x, you're told to sketch is equals to log, let's say negative x. So again, you have to look at the value of the function. X in this case it is negative. We're going to the negative values of x. Y in this case it is the whole function. You're able to see that it is positive in front, so we're going to the positive values of y. So this is our y-axis, this is our x-axis. So it means we're going in that direction. That's where x is negative and y is positive. So that's how we're going. Then we're going to cut at this point at so you can find that point, and you know that on the y-intercept, on the x-intercept, y is equals to 0. So if I had to put 0 there, to be 0 is equals to log of negative x. And you know that if you haven't given you the power, the base is 10. So you have to change this one to exponentials. Like we've said, if you can't solve it correctly, change it to exponential. You're going to change it. You're going to say 10 to the power 0, and 0 is equals to negative x. So of 10 to the power 0 is equals to negative x. 10 to the power 0, that is 1, is equals to negative x. Therefore x will be equals to negative 1 if you're going to solve it. So this point here, it is negative 1. So that's how you're going to solve this one. Let's solve another one. Let's say you're finding f of x is equals to negative log plus x. So how are you going to solve this one? So let's say this is our y-axis, this is our x-axis. You still have to look at the value of x and the value of y. Now the value of x, it is positive, the value of y, it is negative. Why? Because the log itself is negative. So we're going in which direction? Where is y negative, where is y positive? You know that y is negative here and x is positive in this region. So it means we're going in that direction. And you're cutting this point. When you're cutting that point, you know that that point is just a 1. Okay, so that's how we are going to solve this one. Let's solve another one. Let's say you have f of x is equals to, let's say, log, let's say you have x minus 2. How are you going to solve this one? So when you have such an expression, you shifted the x direction. So because you shifted the x, equate what you have to be equals to 0. So x minus 2 will be equals to 0. So x is equals to 2. That's why I've shifted your graph. Initially, if this is the y-axis, if this is the x-axis, initially this is the y-axis is supposed to be the one that is acting as the asymptote. But now because you've shifted the graph 2 units on the other side, so let's say 2 will be here. This will be 2. So our graph is going to be alternating here or on the other side. Okay, so what are we now going to find? We've said, what about the value of x and the value of y in terms of the function? The value of x, it is positive, so we're going to the positive values of x. The value of the whole function, it is positive. We're also going to the positive values of x. So it means we're going in that direction, going like that. Now if you're going in that direction, you're going to cut this point. So you have to find that point. And that point is on the x-intercept. On the x-intercept, y is equals to 0. So we're going to say y is equals to log of x minus 2. We've said the base is 10 if they haven't given you. So it will be 10 to the power 0. 0 will be equals to x minus 2. So 10 to the power 0 is equals to x minus 2. 10 to the power 0 is a 1 is equals to x minus 2. So I'm going to take the negative 2 to the other side. Therefore, x will be equals to a 1 plus a 2. So x will be equals to 1 plus 2, that is a 3. So this point here is a 3. So that's how you are going to solve, this one. Very simple and very straightforward when you are sketching logarithmic functions. Okay, let's solve the last one. What if you have f of x is equals to, let's say, negative log of, let's say, 3 minus 2x. So how are you going to solve this one? Okay, so how are you going to solve this one? So let's say this is our x-axis, this is our y-axis. So we have to look at the value of the function. What is y, what is x? So you're able to see the value of the function itself, it is negative, so we're going to the negative values of y. You're able to see that the function, the value of x, in this case, it is also negative. How is it negative? Because we have a negative 2x, so it means x also is affected by that negative. So this is negative. So we're going in this region. So if we're going in that region, how? Okay, since we don't have any shift, but how are we now going to go? Do we have a shift? Yes, we have to get what is in the bracket and equate it to 0. So 3 minus 2x is equals to 0. So I'm going to have negative 2x will be equals to negative 3. So I'm going to divide by negative 2 on both sides. Therefore, x will be equals to 3 over 2. So 3 over 2, that is like 3 divided by 2. And when you divide, it will be like 1. Is it 1.5? Is it 1.5? So 1.5, let's say somewhere here. If that is our asymptote, it means we're not supposed to touch it. Meaning that's why I've shifted our graph. But now where it's going to fall, it's either fall in this region or in the other region. So I have to find the y-intercept. On the y-intercept, x is equals to 0. So we are finding x is equals to 0. So f of x will be equals to negative log of 3 minus 2. X is saying it's 0. So we're finding negative log of 2 multiplied by 0, that is just a 0. So I'm just going to have a 3 here. Okay, now this is to base 10, so I'm going to have what am I going to have? So I have to find the negative log of 3 over 10. Okay, and what are you going to have? Okay, that's the question. So all we know is that it's going in the negative direction, so I'm going to have a negative number because of the negative sign here. So because of the negative sign, it means I'm going to pass through these points and going in that direction. So this is how you're going to solve, you know, exponentials and the logarithmic functions. This is all and much that you need to know on these two topics. So thank you and see you in the other sessions.